Okay, so what I want to do today is I want to graph this by hand. And then I will do another video on how to graph this data electronically in Excel. So what we have here is we did an experiment where we put different pieces of potato into different concentrations of sucrose. And then we looked at the initial mass and the final mass, and then we found the change in the mass. And then we calculated finally the percent change in mass. And so those are those values here. Okay, so the first thing you want to do is you want to identify what the independent variable is. So the independent variable is what you have control over. This is what you're experimenting on, and this is what you have control over. In this case, you have control over these different concentrations of sucrose. So you physically went and made these different concentrations of sucrose. Now, the dependent variable, this is basically your data. This is what changes. You do not have control over this. If you do change this, then that is called falsifying data. So this is the result of the independent variable. And in this case, we're going to be plotting the percent change in the mass. And so it's going to be this right column that says percent all the way down. So this is what we are going to be plotting. And I know that mathematically, like, it's weird to have a percent, a negative percent, but because this is a percent change, it's legit. Okay, so don't overthink that too much like I did. Okay, so in this case, so at any time you're plotting a graph, you need to identify what the independent variable is and what the dependent variable is. The independent variable goes on the x-axis, and the dependent variable goes on the y-axis. So the independent variable in this is going to be the concentration of sucrose, and that will be on your x-axis. And then the dependent variable will go on your y-axis, and then that is the percent change of mass. And so at very minimum, it's going to look like this. So here we have our sucrose, and then this is our percent delta mass here, or change in mass. All right, so that's what at minimum it's going to look like. Now the next thing you need to do is you actually need to look at your data now. So notice how your data, it ranges from 0 to 1 molar of sucrose. And everything is by 0.1 molar. Okay. And so what you need to do is try to figure out the best way to organize these data points. Okay. And so I'm going to go ahead and show you what I did. Let me turn the page here. Oh, my hands are so dry. All right, so what I did was here, is that I found that giving it about 4 spaces on the graph paper got it near the end. Do you see that? So this is like 0. Actually, it's 3. 1, 2, 3. Yeah, so 3 little squares. And so the middle here is going to be 0.5. This is like 1.5. This is 2.5. And so I gave it 3 spaces. And that's the best way that I could utilize the space that I have, because we're given this graph paper. Okay. The other thing that I noticed in some people's graphs is they didn't label their axes, and you absolutely need to label it. And so this case, it's sucrose, the concentration of sucrose in molar. So this is how I decided to space it out. If you did a little bit different, that's totally fine. This was, in my opinion, the way that I did it was the best way to utilize the space. All right, so this is the part that's a little bit challenging, is the change in the mass And so you want to look at your maximum and your minimum. And so the maximum here is 88% change. And then the minimum looks like it's about 30.1 around there. Okay. I'm sorry, about 31, negative 31. So the highest is like 88.4. The lowest is going to be around negative 31. Now this is a little bit tricky because you're going to have to find space for positive and negative values. So what I did here is I started with negative 30, which is going to go in this area here. And then I tried to figure a way to utilize the space the best I can here. So it looks like I went up to 90. And if I gave every 10 is 4 squares, it looks like. So between negative 20 and negative 10, there's like, there's 3 squares again. What's going on here? 1, 2, 3. I guess everything was 3 squares. Okay. I don't know why I kept saying 4, but whatever. All right. An illusion. So it looks like I did every 3 squares, I did 10. So increments of 10. Then there's 0. When you graph a 0, you got to put a line across it. Okay. And then we go to 10, 20, 30, 40, 50, 60, 70, all the way up to 88.4. So this is what my graph looks like. I also saw some people do some fancy stuff like doing a best fit line. In this case, you're not going to do that. First of all, I mean, I don't think we could accurately draw a best fit line unless you're really crunching some numbers. And so you're just going to plot it like normal. Okay, and it doesn't look that great. Now, one of the questions is, where is the no change? Okay, where is it that there's no change in mass? And that, oh, thank you for the tomato. Look, I have a weird obsession with tomatoes. I love tomatoes so much. Like I want to marry tomatoes. Anyway, my son just brought me one. Thanks, son. Yeah, it's a giant one. Mm-hmm. And so do you see how it crosses 0 here? Which is very close to this 0.5 molar area here. But where it crosses the 0, that's where there's no change. Okay, and so that's where your answer is. So if it's close to 0.5, you're GTG. Okay, that's totally legit. All right, so that is how this is how the best way, at least for me, I plotted it. If I saw something similar to this, then that's cool. Okay, and again, I labeled my axes, okay? All right, so now the next one I'm going to do is I'm going to teach you how to do this in Excel. All right, thank you.